So total profits of firm A, 4.5. Right? These are solutions to the profit maximizing problem. So in equilibrium, firm A will produce 1.5 units of output, firm B will produce 1.5 units of output, firm A and firm B collectively produce 3 units of output. So price would be, as we said, 4 rupees, and the total profits for firm A would be 4.5, and similarly total profits of firm B will be 4.5. To solve this, total profits of firm B also will be 4.5. So total industry profits will be 9. Right? Okay? Sure. Now, I want to ask you a question. Does this thing seem sensible? Does this whole thing look plausible to you? Do you think this model, we have done this analysis, does this analysis look sensible to you? Or do you think there is something fundamentally wrong with this analysis? Something missing in this analysis? Or does any question come to your mind? Look here, what's happening? There's a river. In that river there's a platform, and there are these two guys who don't talk to each other who are fishing. There is no communication between them. Currently they are not talking to each other. All that they are doing is they know this profit, so they are working out what is my optimal reaction to my profits, and then they are to the other person's output. No, because they know for sure that this is the demand curve. They know each other's marginal cost perfectly. They know the market, right? They know what's the demand curve in the market, because I have apparently worked for them and told them from econometric model that this is the demand curve, right? They have the only thing they have to do is they have a box in which they have got earthworms, and they put their earthworms on the hook, and each of them knows what the earthworms cost, and they also know from where the other competitor buys the earthworms, so they know the cost, right? And that's all they know, require, right? But the problem with this is, now think of a situation where one of this, so firm A tells firm B that look here, you're making 4.5 rupees profits every day, please don't come to work from tomorrow, right? What I will do is, I will be the only one who will catch the fish, sure, don't come here, whatever profits I make, I will give you half of it, right? But I will be the only person catching fish. You are not going to show up anywhere, right? You will be sent the money every day home. Do you think firm B will agree?
Why not? They don't have to do any work.
Pardon?
If they don't have to do any work, they can just get into profits out of that.
Yeah, but the question is, will he get more profit? So the whole question is, will he get more money or less money? If he gets more money or the same amount of money, he will be happy not to work, right? Okay, and therefore the plausibility of all this analysis depends on you saying that, you know, if this second arrangement is there, if firm B doesn't come to work and firm A decides to share the profits equally, firm B must actually make lower profits for this arrangement to be sensible. So let us see what happens if firm B doesn't come to work. So the argument there is firm A will produce output, right? Firm A will produce output, who will be the only one who will be catching fish, and then will be sharing the profits equally with firm B. Firm B will not nowhere be involved in the actual production process. Firm B will be a sleeping partner, will be at home, right? Okay, so let's look at what happens. Now there is no QA, QB, right? They just Q. In effect, firm A is becoming the monopolist now. We have gone from an oligopoly to a monopoly. They only Q. So what is the total profits now? Total profits now is only pi, which is total revenue minus total cost, which is small c into capital C. What is P now? P is equal to, sure? Just because these guys have worked out some arrangement among themselves doesn't mean that the market will change. The market will continue to be what it is. But what will change now is therefore PQ will be, so PQ minus CC is equal to 10 minus 2Q into Q now. Because firm A is the only producer. Sorry, it should be CQA, right? I'm sorry, it should be CQ. CQ. Right? C is 1 by assumption, so CQ. This becomes 10Q minus Q. I need to maximize this with respect to Q. Sure? This is 9Q minus 2Q has 2Q square has to be maximized with respect to Q. Right? So, Q is equal to
9 minus 4 Q.
yeah, right? So nine by 4. What is 9 by 4? 2.25. 2.25. So first thing that has happened is the quantity of fish sold has gone down. Right? The quantity of fish sold has gone down because earlier how much fish were being sold? Each one was catching 1.5. So collectively how many fish were being sold? 3 kilos. Now how many fish are we catching? 2.25 we are catching and selling only 2.25. The output will go down. Right? If output goes down, what do you think will be the price in the market? The price in the market is 10 minus 2Q. Right? So price in the market is 10 minus 2Q. Right? Price in the market is 10 minus 2Q, or price is 10 minus 2 into 2.5 is what? 2 into 2.5 is 4.5. So 10 minus. So what has happened to the price? Price is increased. Why? Because the quantity has fallen. Sure? What is the total profits now? Total profits by P into Q minus Q. Right? So it is 5.5 into 2.25 minus 2.25. Sure? How much is that equal to, friends? How much is 5.5 to 2.25 minus 2.25? 10 point. You separated minus 2.5. So this is the total profits in the market. Half the profits have to go to firm B. So how much does B get? How much is that? 5.06. How much was he getting earlier? 4.5. Now without coming to work, how much is he getting? So why should he come to work? If you're firm B, will you accept this? You have to come here, catch fish every day and take 4.5 rupees home every day. But if you don't come at all, somebody is running your business and sending you 5.06 rupees. Right? So the important question, so many things are important. The first important question then is, why do such structures exist? You see markets where people are producing, there is a small number of producers who are producing almost identical products. Right? Why are there so many of them? It says that if firm B gets out, then actually firm B will make more money. There is only one producer. If you change from oligopoly to monopoly, actually everybody will be better off. So the important question that you have to ask yourself as a review question is, why do such oligopolies exist? Right? Why do such oligo? For example, if you go to Kalina market, you will see lots of people selling spinach. That's a situation identical to this. Everybody is buying spinach from the wholesale market at the same marginal cost. They're selling the same output undifferentiated. You can't really differentiate spinach sold by the one person in the market from another. So why are there so many vegetable sellers? Why don't they work out an arrangement where only one person sells the vegetables, right, and shares the profits with all others? Everybody will be better off, no? So please worry about this puzzle. Every time you pass a vegetable market, you are actually passing through a puzzle through an economist. Sure, so wonder about this, try to find out. That's one of your review questions. Why do such vegetable markets exist then? Right? Why do you see so many fisherwomen in the fish market? Why isn't there just one person selling all the fish, acting as a monopolist, and then distributing profits, which will make everybody better off? So why do people actually take the trouble of getting up in the morning, going to Princess Rock, buying all those fish, carrying them to the market, sitting in their days all day, whereas you could actually be doing something else? You could actually be sitting at home and watching TV, right? So why does this happen? That's an important question. The second important question that I want to ask you is, why are profits lower in an oligopoly? In the Purna model, profits were lower than what they would have been in a monopoly. Why? Can you give me a good economic reason?
Economies of scale. Because if you combine the two factories, a firm which is remaining firm will enjoy economies of scale.
No, but I have not said anything about production technology, right? I have said that they continue to have the same marginal cost. So there isn't any economy of scale. See, what happens is, when there are two producers selling, then each one is imposing an externality on the other. That is, if I sell more fish, then there is an externality because the price in the market falls, and which hurts the other player. It's just like pollution, for example. When I drive, I impose a cost on others, which is the pollution, which I don't factor in. Which your first year public economics would have told you, or public economics now will tell you, that there will be too much pollution, because nobody will take into account the social cost of pollution. That's an externality. Similarly, when there are two sellers, each person decision to sell increases the quantity sold, actually lowers the market price for everybody, and therefore imposes an externality, negative externality. We know that if there is an activity which imposes a negative externality, there will be too much of that activity relative to the market optimum. Right? So what you see here is actually that kind of an externality. There are too many fish being sold. There are too many fish being sold. Right? If you translate this to fish caught, then you mean there will be too many fish caught relative to what the market should be catching. Right? From the point of view of the market as a whole. Right? So it means that if the stock of fish is limited, right, it might perhaps be extinguished because there are too many fish being caught. So one solution actually to reduce the number of fish caught in order to sustain the resource is to say that let each individual fisherman stop catching, let us create a cooperative union of fishermen, let them collectively catch fish as a union and sell as a monopolist, and then divide the profits equally, which means that everybody will be better off, but because fewer fish will be caught, that will actually conserve the resource. Right? Okay, so please don't regard the Purna model simply as a model which says that this will happen. There's actually a lot of learning that comes out of it, which you have to apply to the to the real world around you. Right? So what this tells you is, if there's a cooperative, for example, essentially a cooperative, right? A cooperative will make more money than an all individual sellers selling individually. So if there are people who are, instead of individuals, milking their own cows and taking the milk from door to door, if they form the cooperative, there will actually be more profits because the cooperative can act as a monopolist. And if but what is the impact of that cooperative? That impact of the cooperative, the price in the market will go up and the quantity will fall because the cooperative is now a monopolist. The market structure has changed. So you cannot expect the cooperative to benefit the milkmen as well as the consumers. Right? You can't have it both ways. Sure? So that's how the Cournot model works. Okay? Is the idea of a Cournot model clear to everybody? What are the basic assumptions of a Cournot model? They're clear? Right? How does one derive reaction functions in the Cournot model? Is it clear? And the learnings from the Cournot model are that obviously, right, what the Cournot model says. The Cournot model in a sense talks about a situation which is difficult to visualize, because when people can actually combine and make more profits, it's difficult to understand why they should be acting as individual producers. Right? So somebody needs to get them together and form a collectivity which will then act as a monopolist, and everybody would actually be better off. So the reason that does not happen in many times, it must be because it's very difficult to form collectivities. It must be very difficult for various reasons to form a union of say vegetable vendors. Right? Which are all costs, which are maybe the transaction costs of doing that are too high. Right? So one must understand, so I think one puzzle that I've thrown at you is try and understand why there are so many fishermen, so many fisherwomen in the market, or why there are so many vegetable vendors in the market. Probe, talk to them. Next time you are in the market, go to your regular bhajiwala and just throw this idea. And you will understand what the difficulties are, and then try to make sense of those difficulties as an economist. Try to see whether you can put them into this model, and try to understand why you observe what you observe. Right, because ultimately microeconomics is not about writing some equations here and showing some equilibrium. Microeconomics, we do microeconomics because it helps us to understand the real world around us. We apply the ideas from microeconomics. Right, many ideas from microeconomics are patently artificial. Right, for example, indifference curves don't exist in the real world. Demand curves don't exist in the real world. But they are tools of analysis. They are mental tools which we use to make sense of a very complex world. For example, without this structure that I have outlined, this would not have also occurred to you that what you are actually seeing in the market is something very strange and something that needs to be understood. Right? Okay, so that's the reason, that's the way you should apply microeconomics to the real world. So next time, some of you are going to tell me why there are so many different vegetable sellers in the market who are selling the same spinach, the same brinjals, the same watermelons, right? Instead of combining together and forming a cooperative or some kind of a unit. Sure? Okay. Now suppose I wanted to change the assumptions of this model. Suppose I wanted to change the assumptions of this model to a situation where both the producers do not have the same marginal cost. They face different marginal costs. Right? One of the fishermen learns that actually you can get cheaper earthworms somewhere, and goes and gets those cheaper earthworms and doesn't tell that to the first fisherman. Right? How will the equilibrium change? How will you solve for such a model? How will you solve for such a model? What do you think will be the implications of such a model? Cost switching. So now we'll do things a little bit abstractly. Okay? We'll do things a little bit abstractly. So now we'll say that the price in the market obviously is, so we'll keep the price the same. Okay? 10 minus 2Q. Okay? We'll say that the marginal cost for the first producer is C1, the marginal cost for the second producer is C2, okay, and we'll assume that C2 is greater than C1. We'll assume that C2 is greater than C1. What do you think will be the implications of this? C2 is greater than C1. So what will be the, so let's now calculate the equilibrium output for the first and the second player. Profits for the first player is minus C1 QE. Sure? This is 10 minus C1 QA minus 2 QA square, right, minus QA QB, right? 10 minus C1 QA, so this is pi. Max pi A with respect to QA, max pi A with respect to QA, you get 10 minus C1, okay?
4 QA.
Minus 4,
Four
yeah, minus 4 QA, QA,
QA.
QA, QB. Yeah? Right? Or the reaction function will be, the reaction function for player A will be 10 minus C1 or yeah? So reaction function for player A, I write this here, is QA is 10 minus C1. Sure? Right? Reaction function for player 2 would be what? Right? By the same logic. How do you 10 minus C upon 4. Yeah.
4.
Yeah, 10 minus C2 upon 4. Right? Minus half Q. Now, can I get rid of all this? It's now very simple, right? So what it means is, so QA is equal to yeah? What have I done? I substituted for QB.
QB.
This is sure? So I have I have to multiply by 4. Yeah? You're right. You're right.
Then minus, no? Minus.
Yeah. That's right. So I just
Minus.
See, if you open this bracket, this will be plus.
Plus.
So if I take it this side, it's minus.
Right.
Right? 3 by 4. Right? 3 by 4 QA. So that is 3 by 4 QA. Right? So I have got. And so QA is equal to so QA will be equal to 3QA will be equal to 10 minus C1 minus 2, 10 minus C2. Sure? Because I am multiplying both sides by 4. This will be 10 minus C1 minus 20 plus C2. Pardon?
Upon 8.
Upon?
Upon 8. So into 4, if you do this, it will be upon
Yeah. So if I divide by multiply by 4, yeah, this will have to be multiplied.
Upon
Yeah. So this, if I multiply this by 4, this will be upon 2. You're right. So 3QA is equal to 10 minus C1 minus, yeah, upon 2, which is 10 minus C1 minus 5 plus C2 upon 2. Right, so QA will be equal to 10 upon 3 minus 1/3 C1 minus 5 plus C2 upon 6. Right? Now you get an important quantity. You get an important relationship. What is that important relationship? That important relationship says that quantity produced by A